much more vocab on the analyzing part of our scatter plots. So we're going to be making them. That's just on an XY coordinate grid. If you look at this picture, this is a picture of a scatter plot. That's an example of one if you are looking at that. Identifying independent and dependent, you've been doing that kind of all year, but always thinking that our independent is our X and our dependent is our Y. Same in science, usually you have the independent is what you choose or you get to pick. It's a lot of times your time, and Y is the other variable. We're going to be constructing them using appropriate scales, so making sure sometimes you'll do a broken bar graph. So when we are looking at that, we might not have going from 0, but you might have it broken like this because maybe you're going to start at 30 and then at 40, but you don't want to go all the way down to 0. So a lot of times we might have what's called a broken bar graph. We're going to talk about in our vocab the outliers in ours. We're going to talk about correlation. You'll kind of see the difference between what's a correlation and causation. Sometimes people think those two things, like one variable causes the other, and a correlation are the same thing. So, and a lot of times you'll hear people using that vocabulary, like this causes this, or they'll use causation instead of when they meant correlation. So we're going to talk about that. I'm going to show you this website that we're going to look at. So as we read the vocabulary, Lulu, you want to do me a favor and read where it says scatter plot?
A scatter plot is a graph of bivariate numerical data. The data points are displayed on a coordinate plane as ordered pairs. Most scattered plots occur in first quadrant because real world data is often positive.
So when you think about that, when we started this unit, we had 2 variables. So this is still bivariate, 2 variables, but this time it's numerical data instead of being in a category. Christian, you want to keep going for us?
When we look at the data on the scatter plot, we can identify many patterns.
Keep going.
For example, the data generally follows a straight line. We can call it linear. If it does not, we can call it nonlinear.
So if we were looking at this data, does this look pretty linear?
Yeah.
Because I put like a line of best fit, could I put a straight line kind of through that data and have half the data points be above and half the data points be below it? So if we're thinking of that, if I could look at this and I could draw this line, now someone else could have said nonlinear because they said it could have gone like this, right? So I would take either answer, you just got to be kind of specific. This, I would probably say this is probably a little more linear than nonlinear, but both of these, this curved line, could be a case also. So what we're going to be talking about as we continue, Evan, you want to continue with our vocabulary there?
Is it optional?
No, go ahead.
Another way to analyze your data is to look at its correlation and its strength.
Keep going.
Correlation is positive when both variables are increasing. Correlation is negative when one value decreases as the other increases. Correlation is strong when the points are more lined up, almost in a straight line. Correlation is weak when the points are more scattered and don't form a line as well. There may be more correlation. Is there no pattern on the data?
So no correlation, no pattern. You can see that one in the middle. This is a strong negative, almost in a straight line. This is a weak negative. It's still going down, but it's not as on a direct line. So they give you a picture of each of those. As we continue looking, Jack, you want to read that next part usually?
Usually the points in a scatter plot form a single group of points, but sometimes the points may form 2 or more distinct groups of points called clusters. An outlier is an unusual point in a scatter plot that does not seem to fit the general pattern or that is far away from the other points in the scatter plot.
So in this one, we have our outliers would be these 2 points that you're kind of looking at from this data. This kind of is all in a nice straight line, and these 2 are kind of just way out of that. They're not in that same pattern. This is just having a cluster of information. It's just that they're all kind of grouped together. So this kind of looks like it's positive, but this is pretty much, there's not that much of a correlation, but it does look at it as your calories per serving increase, the sodium is also increasing. That's what this graph is talking about. So again, looking at all that vocabulary. So on the next page, it's up page 20. You are going to be asked for each scatter plot, circle the correct description for it. So if we were going to start off, and I'm just going to highlight mine, would you say this looks linear or nonlinear? It can't be both, right? It can't be both linear and nonlinear. You're going to have to choose one. Positive or negative? Positive. Strong or weak? I'd say it's pretty strong if we are looking at it. Compared to this one down here with the exams, that one would be a lot weaker, right? So this one probably strong. And did we have any outliers?
Yeah.
That's really weird. Not really if we're looking at it, but do we have a cluster? Yeah, kind of down in this area, right? So if I was thinking about that cluster, I would say that kind of down in this area, this is all kind of clustered together. So what I want you to take a look at is to go take a look at these next 3 graphs and kind of check with the person sitting by you, next to you, in front of you. And let's look at this one on the top. Want to give me, let's do at least the first 2 things that you had. Non-linear and negative. Emma, what else did you have?
Strong.
I have strong also. That sounds good. And we do have a cluster kind of up in here, right end here. So we have clusters. Do we have an outlier?
Yeah.
Yeah, this one way down here, right? That would be a definite outlier if we ever look at that one. Okay, that's way off from our data when we are looking at that one. Okay? As we take a look at that next one, Felix, could it have linear? Okay? And negative, if we were going to keep going. What do you have, Brad?
And outlier, nothing.
Outlier, I agree. Outlier. Not really any clusters, right?
Yeah.
Weak or strong? And for this one, I'd probably take either one. I mean, if you were going to draw a nice line of best fit, which is our next lesson that we deal with, I mean, half the data points are kind of above or below that, but I would have taken either one of these answers for this one. I tend a little more towards the strong than weak, but I would have taken either answer. Okay. And Henry, you want to start us off on the next one? Linear, okay. Could someone have said nonlinear? And then what you just want to do is show me what that line looks like, right? So if you said nonlinear, you said, oh, I think it's kind of going like this, right? More curved than a direct straight line. You just want to show me that, okay? And what else? Which other one did you have beside that? One more. Yeah, clusters. Definite clusters, I'd say kind of in here, maybe in that group. So, all right. So, Greta, what else could we have? Positive, negative. Positive. Have anything else? Weak or strong? I go much more weak on this one, whereas that one was a little more kind of along the line. This one's a little more spread out, so probably weak as we are looking at. All right, so top of the next, or that next page down, kind of the same thing. They're wanting you to, for each scatter plot, correctly look at the description. If there's no pattern, circle nothing. So, kind of looking at that next one again, I'm going to have you do the same. On that first one with Nevada's temperature, and give me the first few things that you have.
Linear.
Linear, okay.
Negative.
Negative.
Strong.
Strong, I'd say pretty strong. Could someone have had nonlinear?
Yeah.
Yeah, because you could show me that it's curved, right? Come and show me linear by putting the straight line if you're looking at that. So on the test, just make sure you show that, or on the quiz. And Elise, what else? Anything else? Clusters, probably. Not really any outliers for this one. If we're going over to the next one, Elise, do you want to start us off with the education and income?
Linear.
Linear. I don't know if I'd go linear with that one. I would probably tend much more towards nonlinear. If I want to think of half my data points above and below where I draw a straight line, like if I do this line, that doesn't include anything up here. And if you think about that, like this one kind of being almost an exponential. We haven't done exponential functions yet. We've mostly concentrated on linear. But this one's kind of saying as you get more education, what should be happening with our income? Does it always happen? Why is this one an outlier? Think about people who may not have a lot of education but they get paid a lot. Like athletes. professional athletes. Some of them might not have gone to 4 years of college, right? And they could be making higher stuff. So if we have this, we definitely have outliers, right? Nonlinear, if we're going to continue, Caleb, what else might we have? Strong and positive. If you put weak, you know, I want you to think about, as your education level increases, are we thinking that our income is increasing? At least for a period of time, like through a high school graduate, right? And maybe going to a 2-year school or a 4-year school or getting more education. So I would, between that weak and strong, a lot of times on the test I'll just ask you to explain. Here, if we are looking at this one, it's not linear, it's not nonlinear, it's not positive, it's not negative. It is definitely weak, and there is really no correlation, right? Or nothing in common. If we are looking at that one, there's no pattern, okay? It's really none of those, and it's very weak, which we would think, right? Shoe size and your IQ. Small feet, large feet, medium-sized feet. We don't think it should affect your IQ. And then as we are looking, Angus, what do you have for this next one?
Linear and positive.
Linear, positive. Anyone have nonlinear? Okay, so again, if we are thinking pretty much strong or weak, if we are looking at that one. Owen, what do you think? I'd probably go weaker, because it is like if you're drawing a straight line, if you wanted to get our data points half above and below, I mean, it is kind of along here, but there's many different lines that possibly could have been drawn with this one. And if we continue, do we have any outliers or clusters as we're looking at that? What do you think, Tristan?
We have clusters.
Definitely. Not really any outliers for this data. There's not any point down here or over here. Okay? So, on the next page is where we're going to be making them, and this is what much more of what your homework is, and then trying to just take a look at it and answer the question. So, to make a scatter plot of the data, first thing you want to do is identify your variables. Usually, we are going to be thinking X, Y when I give you a table. So we're talking about gasoline purchases, so we're going to put that as our title. Gasoline purchases. The next thing we want to look at is our scale. So the dollars that we're spending, if we are looking at that, that's going to be on our x-axis. Go from 4 to 10, or 4 to 13. Could we easily just go by ones? Yes, I'd go by ones on your x-axis. And that is going to be our dollars spent. And we can easily go, because we really only want to get up to 13, so if we go by ones, right, so we're going to have 0, 2, 4, 6. If you wanted to put 13 instead of 14, because that was one that we wanted to do. And choosing if we are looking at our Y. Now this one we might want to go up by what? Or this is our gas that we bought. So 0.5. 0.5? I think 0.5 would be good. 0.5, so then we're going to have 1.0, 1.5. Could you just put the 3.0 or the 4.0? We really don't have to go any higher than that. So now what you want to do is you want to plot your points. So you are going to 10 and 2.5. 10, 2.5. The point. That's a scatter plot when you do that, okay? So please plot those points at best fit. You just need to label your axes. You need to put a title on your graph. So this is an easy, like 1 point for you. Some of you miss that sometimes on that last test when you're graphing and doing those. So now it says describe the data. Your description must include the 2 variables. On the project, the one thing I found on some of the people that turned in their project with the light bulbs, when it said you must include 2 or more details or statistics, and you just told me one thing. I said, oh, standard deviation. That's up to me. You didn't tell me 2 of the things. So when we are looking at describing that, as the dollars spent, what happens? How much gas we get? It increases, right? So I'm going to give you 3 different answers here so you can kind of take a look. A great answer might be something like, you answer the question, say, you get more gallons of gas when you spend more money. The more money you spend, you get more gas. A poorer answer, which would still be an okay answer, but not great, would be that you say, when the X number gets bigger, the Y gets bigger. You're not telling me anything about my two labels that I gave you. You're just talking about X and Y, and you're not being specific to the problem. So, and then the dots go up would be one that I've had, but would not be a good answer if we are looking at you getting points on your list. Okay? Question: positive, negative, or no correlation? The population of a city, so think about how many people in Fargo, how many people in Moorhead, how many people in Castleton, how many people in, I don't know, think of any name of a town. So the population of a city and the length of its name. Do we think that there is positive, negative, or no correlation?
No correlation.
We would hope no correlation. Like Fargo actually has more people than Moorhead, right? So if we were looking at that. West Fargo has more letters. I don't know. I think Fargo is still considered a little larger than West Fargo. So the time spent running and the number of calories you burn. As you run more, do the calories burned go up or go down? Up. So this would be a positive correlation, right? The total money that you owe the bank for a home mortgage. Do you guys know what a home mortgage is? Home mortgage is when you go to buy your house, you don't have enough money to buy it, so you borrow money from the bank. So if a house costs $150,000 and your parents going to buy the house, or I'm going to buy that house, I might only have so much money that I can put down. Maybe I have $20,000 or $30,000, and if they listen, I can put this down. And then the rest is called a home mortgage. So home mortgage is how much you owe the bank, and we're thinking about time. So the amount you owe, each month I have to make a payment on my house. So is the amount I owe the bank going up or going down? Down. So this is negative. But I always think this is interesting to put this in here because a lot of you probably have no idea. Possibly, maybe your parents have talked about their home mortgage. Your height from age 1 to 18. We would think it's positive. Now, is it always positive? There's times when it leveled off, right? You didn't continue growing. But overall, it's usually not negative, right? I mean, by 18, you might have plateaued, and maybe some of you at 15 are at your maximum height. Okay, so now that's the correlation. Now we're at the top of the next page on 22, and this is the causation. So if we are looking at reading, anyone want to volunteer for me before I choose? You're on.
Causation is when a change in one quantity causes a change in the second quantity. A correlation between two quantities does not always imply causation. A study shows that there is a negative correlation between a student's anxiety before tests and the student's score on the test. But we cannot say that the anxiety causes a lower score on the test. There could be other reasons. The student may not have studied well, for example. So the correlation here does not imply causation. However, consider the concept correlation between the number of hours you spend studying for a test and the grade you get on the test. Here, there's a causation as well. If you spend more time studying, it results in a higher grade.
So if we look at this situation, so there's a difference between causation and correlation. So a number of loaves of bread baked and the amount of flour used, if we are looking at that. So what we are asked to look at is, this would be a positive correlation, right? Positive correlation, and it is also, when we look at that, so because when you can make more bread if you use more flour, and it's also causal because the number of loaves baked increases, the amount of flour increases. So they kind of go together when you're thinking about that one. As we look at the next question, the number of mailboxes, I always think this is interesting, the number of mailboxes and the number of firefighters in the city. Now, if your mailboxes increases, that's because what's happening? You're getting more people, and if you get more people, usually you think you probably need more firefighters. But do you have to have more firefighters just if you add more mailboxes? And especially, like if you think of adding it in an apartment complex, all of a sudden you have a ton of them, okay? So as we're looking at this way, it says it's likely to be a positive correlation is what we want to look at. It is likely that there's a positive correlation because both the number of mailboxes and firefighters tend to increase as population increases. So we think, yeah, mailboxes go up, might need more firefighters, okay, there is a correlation. But just because you put in more mailboxes does not cause the number of firefighters to increase, right? There is a correlation, but one doesn't cause the other one to happen. So that vocabulary of it causing it is kind of a correlation does not imply. So you can see that they have the drownings, so going over their time period, the number of drownings, how that went, and how it correlates. Does one cause the other one?
Yes. I think the people are intentionally drowning.
So, I just want to show you this website. So it says, how ridiculous some things look. So the U.S. spending on science, space, and technology, and suicides by hanging, strangling, and suffocation. Now, we think over the years that those have anything. This is the one that we have in the notes, the number of drownings, right? The per capita cheese consumption and the number of people who died by becoming tangled in their veggies. Like, people, I don't know, guys.
People are stupid.
What? Per capita consumption of margarine.
Margarine.